Hello, my friends. I'm Gliperal, and this is Genuinely Approachable Sudoku. I know I'm probably not the face you expected to see today, but Clover's been working really hard, and she deserves a break, so I'm filling in for her today. And today we're solving Cheeky Nandos by Philip Newman. Normal Sudoku rules apply, so in every row, every column, and every outlined 3x3 region, we're going to place the digits 1 to 9 once each. Additionally, in this puzzle, we've got Renban lines. Digits along lines must form a non-repeating consecutive set in any order. For example, if we had a 4-cell line, that line could go 4, 3, 5, 2, because that would be a rearrangement of 2, 3, 4, 5. In this puzzle, what that effectively means, because all of these lines are 2 cells long, is that every line is going to contain 2 consecutive digits. For example, this line, because it already has a 1 on it, this digit must be a 2. This line, which already has a 3 on it, needs a digit that's consecutive to 3, but it can't be a 2 because there's already a 2 in this region and this row, so this has to be a 4. This digit has to be consecutive to a 2, but it can't be a 1, so it has to be a 3. And this digit has to be consecutive to a 4, but it can't be a 3, so it has to be a 5. We can do the same thing down here on the bottom of the puzzle. This digit has to be consecutive to a 9, so it has to be an 8. This digit has to be consecutive to a 7, so it has to be a 6, because it can't be an 8. This digit has to be consecutive to an 8, but can't be a 9, so it has to be a 7. And this digit has to be consecutive to a 6, but it can't be a 7, so it has to be a 5. Because we've got 8s and 7s here, we have to place 8s and 7s in column 1 in one of these 2 cells. This digit has to be consecutive to a 7, so it has to be the 8, that has to be the 7. We can do the same thing with 2s and 3s down this column. These 2 digits have to be 2 and 3, and this has to be consecutive to a 3, so that has to be the 2. And that has to be the 3. Now let's have a look at this line, and I'm just going to pencil mark in the options we have for it. It can't be a 2 because there's a 2 in the column, and it can't be a 5, 7, or an 8 because we have 5, 7, and 8 in the region. So we're left with 1, 3, 4, 6, or 9. But of those options, there's only 2 digits from that set that are consecutive to each other, and that's going to be the 3 and the 4. So we know this line has to contain a 3 and a 4. The rest of the digits in this box, then, are going to be 1, 2, 6, and 9. There's only one place for a 6 to go because of these 2 6s. This digit cannot be a 2 or a 9, so it has to be a 1, and this has to be a 2-9 pair. We can do the same thing on this line, as is typical with Philip puzzles. I'll show you a slightly different way of looking at it because I think it's useful for this genre in general. These 2 digits are consecutive, so they have to contain one even digit and one odd digit. The even digit can't be a 2 or an 8, so it has to be a 4 or a 6. If it were a 4, it would have to be consecutive to a 3 or a 5, but both of those appear in the box already. So the even digit on this line has to be a 6, and it has to be consecutive to, well, not a 5, because there's a 5 in the region, but a 7. And then the remaining digits in this region are going to be 1, 4, 8, and 9. 4 gets placed here by those 2 4s. This can't be a 1 or an 8, so that's a 9 because of this 1 and this 8. And this is a 1-8 pair to finish the box. In this row, we have 5, 6, and 8 left. 6 has to go here by those 2 6s, and these are going to be a 5-8 pair. In this row, similarly, we're going to have a 4 placed here, and this is going to be a 2-8 pair. Oops, not 2, no, a 2-5 pair, that's correct. I pencil marked the correct thing, but I said the wrong thing. In this column, we've got 1, 2, 3, and 4 effectively placed. We know they have to be in these 2 cells, but we don't know which order they go in. 5, 6, and 9. This can't be a 6 or a 9, so that has to be the 5. Neither of these can be 5s. In this column, we have 1, 4, and 5 left to place. This can't be a 1 or a 4, so that's the 5, and this is a 1-4 pair. This line now can't contain a 1, 2, 3, 4, or 5, and it also can't contain a 7. So its options are 6, 8, and 9, and the only 2 that are consecutive are 8 and 9. So we can place those using this 9. That's going to resolve our 1-8 pair up here. It's going to place a 1 into one of these 2 cells. The remaining digits in this box now are a 6 and a 7. And we can place both of those based on this 6. This box now needs 1, 4, 5, and 7. So this is going to be a 1, 4 pair, and the 5 and the 7 get placed here and here. This box, well, let's do the symmetrical deductions here first. This line can't have a 5, 6, 7, 8, or 9, and it also can't have a 3. So the only odd digit I can put on it is a 1. 1 has to be consecutive to 2. So that's a 1, 2 pair. This is a 3, 4 pair, which get resolved like that. This 1, 4 is going to get resolved. This 6, 9 is going to get resolved. And in the center box, we have left to place a 3, a 7, a 2, and an 8. This digit has to be consecutive to a 3, and it can't be a 4, so that has to be a 2. This digit has to be consecutive to a 7, and it can't be a 6, so it has to be an 8. The remaining digits in this box now are 1, 3, 5, and 9. No, sorry, 1, 3, and 9. The 9 is placed here because we have a pointing pair looking at it. So these digits are going to be 1 and 3, and there's a 3 looking down at this box, so that's going to be the 3. That's going to be our 1. There was probably a simpler way to see that, but that's going to resolve all of the bottom rows except for these 2 pairs. In fact, those 2 pairs are resolved as well, because I've got a 2 up here looking down at this. That's a 5, that's a 2, that's a 5, that's an 8. This 1 resolves my 1, 2 pair down here, which means the remaining digits in this box, 3 gets placed here, 5 gets placed here, 6, I don't know yet, but 9 is going to resolve it surely. No, actually, we just have 6 and 9 left to place, and we don't know which way around they go yet. But this box is surely going to sort it out. We have a 1 here, 2, 3, 4, 5, 6, 7 is going to get placed here, and 9 is going to get placed here, and that will indeed resolve all of our remaining digits. And that is how you solve Cheeky Nandos by Philip Newman. If you want to check it out yourself, the link will be in the description, and we'll see you next time.